Related to flow measurement. I did do a stint where I was responsible for all the products that Emerson manufactured under the EPM, which is pressure, temperature, all the flow products, DCS, as well as a few products that were spun off, such as nuclear, K-ray, some of the La Habra products from analytical, things like that. So I've got a pretty good understanding of all the various technologies and how they're applied. I did spend a stint in Asia, about 4 years, and there's a number of very friendly faces that a number of years ago when I was here working, they're still, in fact, I hired some of the individuals. It's good to see them here. One thing you'll find out about me is I always start off a session with an acronym. And I used it 12 years ago when I was in Asia, and I'll use it again. Who knows what that acronym stands for? TANSTAMFL. Who knows what that means? It means there's no such thing as a free lunch. So what it means is you've got to participate. The more you get participation in the sessions, the more fruitful the information will be. Just like this exercise I gave you at the start, it's trying to get you thinking and stimulating you about the flow technologies that are out there. As flow measurement experts, you can't look at just the flow devices that we sell. You've got to understand all the flow devices that are available in the marketplace. They all have pros and cons and where they're applied. Our industry, the flow measurement industry, is really starting to take off. It's actually really accelerated in the last 7 to 8 years. There's a number of different factors that control it. We've got factors from the process industry. We've got factors about customers wanting availability of measurement. We've got factors that affect us from capital projects, from engineering houses, contractors. We've got the regulatory compliance. All of those have an impact on how we're driving the flow measurement technologies today. Some of the recent technologies, and when I say recent, it's within the last 20 years, have really exploded in adoption. Coriolis, ultrasonic, both of those are new technologies. In the respect of overall time of the industry, 20 years is pretty young for a technology. Customers are looking at a lot of changes. You'll find that today customers are losing a lot of their expertise. Some of their senior workers are starting to retire. What they're trying to do is put a lot of that knowledge back on suppliers. They want the suppliers to be able to handle a lot more complex questions, be able to take on the full responsibility of projects and jobs. They're using suppliers as the stopgap between their workforce and their young workers, things like that. Right in the middle of all this, you see custody transfer. It's probably one of the toughest applications there are, and the reason for it is there's a lot of requirements by the regulatory departments as well as governments. In the last 15 years, there's been a lot of change in metrology. If you turn back the clock about 10 years ago, there was a lot of talk about harmonization of standards. What that means is countries were starting to work with other countries and say, okay, if I get one approval in this country, we want to make our standards harmonize with yours, so if you get the approval in that country, you could apply it in this country over here. One of the world areas that took a very dramatic change in that is Europe. They came out with what was called MID, Measurement Instrument Directive. Basically what that is the total EU organization, the 23 countries that make up the EU, they all got in agreement that said, if you get your device certified under MID, and there's two parts of MID, which is one is the electrical approvals and then the metrology approvals, we could stamp your device that you can now sell it in any of the 23 countries without having to go through a reapproval. All the manufacturers thought that was a great idea. Now you fast forward the clock. What's happening? MID has been in practice for about 7 years. What they're starting to find out, that those governments that signed up for these harmonized standards are starting to determine that they're losing revenues. Metrology approvals was a source of revenues for a lot of these countries. So what's happening is these countries now are saying we want MID, but they've now come in with another standard over and above that. So you to sell in their country, they're starting to introduce these new standards. France recently was one of the first countries that said, yeah, we want MID on everything. Lo and behold, within 18 months of accepting MID, they rolled out what's called COFAC. It's another standard that we have to comply to, but as soon as we get COFAC approval, we're paying the dues to the French government for the metrology in France. It's directly opposite of what the harmonization is requiring. Recently, Dave and I were in Italy on a conference, a metrology conference, and we're finding out that Italy now has implemented another regulation which is 90 days after you implement the technology. They want another approval, another witness. So we're seeing that the industry is continuing to change with changes in the regulations. I was in Asia when there's a lot of the countries were just starting to grow and evolve. I remember being in China when our Coriolis revenues are someplace around $6 to $11 million. Today, I think it's pushing close to 60 or 70 million. What's interesting, China has actually signed acceptance of OIML, which is the overall governing metrology regulation, but yet they implement, and they said, oh, we need our local patent approval. So that's another way of governments trying to put some changes on the industry and make it more in line with what they want. The other thing that's really changed for us is a lot of the emerging countries are starting to come up with their own metrology regulations. The thing that's really interesting is if you go back again, last 10 years, you'll find those countries, yes, you had foreign nationals working and developing and exploring and starting to export hydrocarbons, things like that. But the countries themselves, they didn't have the knowledge of a metrology organization. So they would look at their sister countries and say, okay, if you've got that approval in that country over there, we'll accept it. Today, these countries are actually setting up their own metrology departments. That's actually a good thing. The bad thing about it, the type of people that are actually working in there actually have no knowledge of measurement. They have no knowledge of how you validate equipment. So when they're putting out these approvals, we've got to be aware of them because in certain countries there's absolutely no infrastructure for validating the measurements in country. And their rules are such that it doesn't matter what the oil company does or what we do, we won't be able to get a final approval. So it's really important to really understand the flow measurement, what they're going to apply the technology on, what they're trying to do, and if there's any special approvals that we have to pursue. But all of that really affects our industry. My presentation today is I'm not going to go into any detail of any flow technology. You'll hear from the product managers the rest of the week. They will actually be talking about the specifics of their products, the theories, how you how that does the measurement, how they do the sizing, how they do the differentiation and all that. What I'm going to be doing over the next couple of hours is establishing the foundation for all of you on getting a base grounding knowledge. And then also sharing with you what are the key important takeaways. If you only remember one or two things, what are they? And if you know those, that will actually help your job and be able to communicate back to the factory, the support people, a lot more effectively in being able to get the right solution and right answer for your application. There's going to be a lot of basic slides here. This is a definition. How many have actually gone to Wikipedia to look up something on the internet? Wikipedia will become your best friend. It is a phenomenal database of trying to find out technical information about various aspects about our business, about measurement, about oil and gas industry, how things are done. It's a wealth of very good information. I'm not going to read this definition to you, but it's directly straight out of Wikipedia, and I suggest that you start using it. If you're not quite sure of something, just go to Wikipedia, type it in, and it'll pop up some of the information, and it's very, very useful. But really, flow measurement starts with three things. You've got the fluid, you've got what is flow, and then what is the measurement. Here's a definition of fluid. A fluid is a substance that is unable to resist the application of a shear force without undergoing a continuing deformation. Fluids can be liquids or gases. If you've got a container, if you've got a fluid in it, that fluid will take on the shape of that container. Basically, here's a picture of a juice jug with a fluid in it. You can see how it takes on that shape. The most basic principle is for flow, you're actually measuring, other than a PD meter, you're not actually measuring the volume directly. You're measuring something else which is inferring the flow measurement. Other than PD, you're typically measuring a velocity of that fluid going through it. Using a cross-sectional area that a pipe, you could then determine the volumetric flow rate. In addition, there's other devices that could give you flow rate. Suppose you're using a mass meter or a weigh scale or a belt scale, and you want to know what flow is on various situations. You could take actually the mass divided by the density of the product and actually get a volumetric flow rate.